Hello everyone, I am Priyanka Sundaram and my project partner is Neeti Shetty. The title of our project is Parking Reservation System. This is the outline of our presentation. Moving on to the goals of our project, the primary goal of our project was to develop a system which helps the users to reserve parking lots at a given uh, time and date. So our current system allows the users to see the availability of a parking lot at a particular date, and the users also can book parking lots for a specific time period, and they are allowed to enter the parking lot only during their reserved time. We have also simulated the action of an entry and an exit cam. By manually uploading the image of a car with a license plate and keeping track of the entry and exit time. This in turn helps us to check whether the user entered and exited the parking lot only during his reserved time. If he happens to exceed his reserved time, then a fine would be calculated accordingly and displayed to the user. Let's take a look at the components that we have used for this project. For the front end, we have made use of Node.js and React. For the database, we have chosen MongoDB Atlas, which is a NoSQL store. We chose this for flexibility reasons. The REST server is implemented using Flask, which in turn handles all the user requests. RabbitMQ is the message queue which we use here. So it acts as a broker between the REST API and the workers. We have also used RabbitMQ because it helps with the logging and debugging. We use Google Compute Engine to spin up virtual machines and to host services like REST. The OpenALPR software helped in the image recognition. So here we have used this OpenALPR to recognize the license plate from the image of cars. Docker helped us to containerize all our modules, and all these Docker images are deployed in a Kubernetes pod. Kubernetes also helped in scalability of those deployments. We've used multiple workers to distribute work among different nodes. Moving on to the architectural diagram of a system, the users interact with our system through the front end, which uses Node.js and React. So the user can make any request here, like they want to book any parking lot for any specific time period. So such requests are handled by the REST API here, and all the GET requests are directly put to the queried from the database, while all the put and post requests are sent to RabbitMQ and then queried from the database and given to the user. So let's take a scenario where the user wants to enter the parking lot. So in that case, all the image from the entry camera is taken and sent to the REST API. The REST API then places it in RabbitMQ. So the workers consume that image from the RabbitMQ and recognizes the license plate in the image and queries it from the database whether the particular license plate has a booking or not. If the particular license plate has a booking, then the user is allowed inside the parking lot. Otherwise, there is an error message which is displayed in the UI. So coming to the debugging and testing, for debugging purposes, we made use of both RabbitMQ and the Kubernetes. We implemented a logging server which read the logs from the RabbitMQ, which in turn was used for testing purposes. And since Kubernetes already has a logging mechanism, we made use of those commands to view the logs from Kubernetes. And for testing the APIs, we wrote a test script to call each endpoint separately, and we checked the logs from the Kubernetes and RabbitMQ to make sure that the data was populated correctly. And in the web, we simulated a action of an entry and exit of a car from the parking lot using the two forms, one for entry and one for exit. This we used to check if the actions and all the APIs were working properly. So some of the learnings to be taken from this project are one is that if this current system has to be scaled for a large scale for a parking lot with a large number of incomings and outgoings every day, we have to make sure to automate the process of creating workers so that the system would be robust. And testing was particularly challenging in this situation because we had to test every API separately and we had to implement the simulation of the camera manually and check whether the data is getting populated right or not. But the use of Dockers and containers were of great help because it helped in simplifying the scaling and deployment process to a great extent. So some of the potential bottlenecks that our current system could run into is that we just have a single REST server which is running. So if the server goes down or crashes, there is no other server to take the load of that. So for the same reason, the UI cannot handle multiple requests as well because if there are more web servers and a load balancer to balance load among the servers, then multiple requests would be a piece of cake. But as of now, we don't have that implemented yet. And also, we should make sure that there are no simultaneous writes to the database so that even the user doesn't end up stuck because two, two or more users have clicked the same parking slot for the same time. The working system will now be demonstrated by Niti.
Here is a quick demo of our project. This is a UI of our project where we built a parking reservation system, and you can see these green ones are the available slots and the red ones are the booked ones. So on load, it shows today's date by default, and it shows the availability for today. So let me try booking a system, and this was built using React.js and Node.js. And let me try booking. So as you can see, the start time has got populated here, and if I select this as the end time got populated here, and I want to put a license plate for making a reservation now. So the license plate, let me put CZTHEDA. So this is basically the this one. I'm putting this so that later the image recognition should detect this one. So I've booked the slot for the given time and the license for the given license plate. So let me select the date here. And time is, so let me select, so this is the entry time. If I give 5 a.m., it lets me enter. So let me try giving 8 p.m. say, which is, and I do not have a booking for this one. And I choose the image, the same car image, CZTHEDA. I try to submit. It says no booking found. But now I just changed the time from 8 to 5. I had the booking from 5 a.m., right? So 5 a.m. And now it's able to find a booking, and so I can go ahead and park the vehicle now. So while exiting, I'll choose the date. Say I type in 8 a.m. It says, which is correct, right? My end time is 8 a.m. And I choose the image, submit. It says find you as 0. But if I change time from 8 to 8:30, which is like half an hour delay, it charges you a fine of $40. So this is how we tested our system. These two are for especially for testing. So in a real scenario, what happens is there would be a live camera which would which would capture the image and send us. But here in our project, we'll have to upload the image of the car with the license plate, and it will be able to detect using the ALPR. So let me show you a quick demo of the APIs that we have written, the REST and how it integrates with the worker and the RabbitMQ. So to begin with, let me make a booking. Uh, so I have my workers and REST running. This is the REST server running. These two are the workers that are running. This is for the log, and this is for the RabbitMQ task management. And here I'll be running the client. So these are we have written client script for testing our APIs. So here I'm trying to make a booking for CZTHEDA of slot for slot 3 on 12th of December 2019 from 11 to 12. It says it's successfully reserved. Now let me get all the bookings for this date. So we have booking for slot 3 and 4 on that day and this time, starting from 11, and ending time is 12, 11 to 12. Also, now let me try to enter the parking lot at 10:45, whereas I have the booking at 11 o'clock. So this API register entry takes in three parameters. One is the image of the car where there is license plate, and this here we are using the same technique like our lab 7, where you try to extract the license plate. So it extracts the license plate and sees if that license plate has any booking. Um, so it says no booking found for that time and that license plate. It says successfully registered entry, which means you can enter the parking lot since it was able to find your reservation. So now let's try to exit the parking lot and let's see what happens. Let's try to exit at 12, which is the expected time. It says our fine is 0 because we are exiting like exactly at the time we have reserved. So let's try to exit it at 12:30, which is beyond our reservation time. Reservation is only to 12, so we are getting a fine of $40. So these are the main APIs that we have written for the front end. Yeah, that's it. Thank you.